Hello, students. We start our lecture by interchangeability, standardization, and technical measurements. Lecture number 6, Team 6. Interchangeability of threaded connections. The plan of our lecture: 6.1 Basic parameters of cylindrical threads. 6.2 General principles of interchangeability of cylindrical threads. 6.3 Total tolerance of the average thread diameter. 6.4 Reduced average thread diameter. 6.5 Tolerance for metric threads. 6.6 Thread accuracy degrees. And 6.7 Designation of thread tolerance and feed tolerance fields. So now we start item 6.1 Basic parameters of cylindrical threads. A threaded connection is a connection of two parts, one of which has an internal thread and the other has an external thread. Common to all threads are the requirements of reliability or durability and connections without adjustment independently manufactured threaded parts. It is much more difficult to fulfill the requirements for the interchangeability of threaded connections then smooth ones sign several parameters simultaneously influence the nature of the threaded connection. V-profile for ISO general purpose metric screw threads. Cylindrical thread parameters. Average or middle diameter, D suffix 2, small d and big D suffix 2. Outer diameter, D without suffix, small d for the external thread and big D for the internal thread, small d for the bolt and big D for the nut. And outer diameter, it's major diameter. And the third diameter, it's inner diameter of the thread, D suffix 1. Inner diameter, D suffix 1. Big D is for the internal thread, for the nut, and small d we use for the external thread, for the bolt. Another parameters, it's pitch, big P, distance between two peaks, profile angle, alpha, for the metric thread, alpha is equal 60 degrees, and the height of the original triangle, big H, original triangle, and H its height of the original triangle. The thread pitch P is the distance between adjusted profile sides of the same name along the average diameter. Metric threads come in large and fine pitches. V-profile for ISO general purpose metric screw threads. You can see the same parameters on this figure. Metric threads come in large and fine pitches. For a thread with a large pitch, there is dependence. D is equal 6p to the power 1.3. For threads with fine pitch, different pitches can correspond to the same outer diameter. Item 6.2. General principles of interchangeability of cylindrical threads. A real thread, compared to a theoretically accurate one, has a profile and size deviation. The accuracy of the threaded surfaces is determined by the accuracy of the outer, medium, and inner diameters, pitch, and profile angle alpha. For threaded mating surfaces, the listed nominal dimensions are equal, therefore, to ensure the connection of paired threads, it is necessary that over the wear lengths, the actual dimensions of the external and internal threads do not go beyond the nominal contour, which is the largest limit contour. Limit and actual deviations of all diameters are counted from the nominal profile in the direction perpendicular to the thread axis. In most threads on the outer and inner diameters, the provided gaps or clearance and tolerance fields are arranged so that as a result, the errors in the diameters d and d suffix 1 do not prevent the connection. Therefore, the connection depends only on the accuracy of the average or middle diameters, d suffix 2, or major diameters, pitch p, and profile angle alpha. Thread pitch deviation is the difference between the actual and nominal value of one or several turns. Here, n is the number of turns located at a given length or at the length of the connection. Deviations of half of the profile angle, alpha divided by 2, is the difference between the actual and nominal values of half of the threaded profile angle. And now item 6.3. Total tolerance of the average threaded diameter. The accuracy and connectivity of the thread is determined by the average diameter, the accuracy of which is normalized by the total or full tolerance. We use the formula big T suffix D2 tolerance field on average diameter is equal delta small d suffix 2 plus f suffix p plus f suffix alpha. In this formula, delta d suffix 2 is the tolerance of the actual average thread diameter. F suffix p, geometrical compensation of the thread pitch deviations. F suffix alpha, geometrical or diametrical compensation of deviations of the half angle of the profile. And now 6.4, reduced average thread diameter. Reduced average diameter for external thread. We use the formula on your screen. For internal thread, we use another formula, except plus we use minus. In these formulas, F suffix P is diametrical compensation of thread pitch deviations, and F suffix alpha diametrical compensation of deviations of the half angle of the profile. The reduced diameter is the average diameter of the theoretical thread that does not have deviations in pitch, profile, angle, which is connected to a real thread without clearance and without interference. 6.5 Tolerances for metric threads. Deviations are measured from the nominal profile in the direction perpendicular to the thread axis. The tolerance field is formed by connecting the fundamental deviation and the tolerance value, which depends on the degree of accuracy of the thread. When connecting the fundamental deviations h, big H, and small h, it's a tolerance field. The fundamental deviations of tolerance field of the hole is big H, and fundamental deviation of tolerance field of the shaft or bolt, small h. With the relevant tolerances, a fit with S minimum, its minimum clearance, is equal 0, is formed. The minimum tolerance is 0. All other connections form fits with a guaranteed tolerance. S minimum is bigger than 0. Minimum clearance greater than 0. And item 6.6, thread accuracy grades. The following grades of accuracy are established for clearance fits. You can see in table 6.1, accepted grades of accuracy. By external thread on inner diameter, on diameter D, grade of accuracy we use 4, 6, and 8. On the middle diameter or average diameter or D suffix 2, we use 3, 4, 5, 6, 7, 8, 9 grades of accuracy. For internal thread, on average diameter, we use 4, 5, 6, 7, 8 grades of accuracy, and for internal diameter, 4, 5, 6, 7, 8 grades of accuracy. D suffix 1, it's internal diameter, and D without suffix is external diameter. If we use small d, it's diameters of external thread of the bolt. And when we use big D, it's diameters of the internal thread of the nut. Numerical values of tolerances increase with increasing digit, which indicates the degree of accuracy. The main deviations, except small h and big H, depend only on the pitch of the thread P. Tolerance fields are selected based on the length of the screw. Tolerance fields are selected based on the length of the screw. There are lengths of screwing: small S, normal N, and large L. Table 6.2 fields tolerances of threaded connection. You can see degree of accuracy, intervals degree from 3 to 6, from 5 to 7, and from 7 to 9 degree. Length of screwing, as you can see, small s, normal n, and large l. Again, small, normal, large, and normal and large. And tolerance fields that can use for external thread and for the internal thread. For the external thread, it's average or middle diameter on the first place, and on the second place, it's for the outer diameter. For the internal thread, for the nut, on first place, it's average or middle diameter parameters, and 5H is for the inner diameter of the thread. Parameters of inner diameter. Designation of thread tolerance and feed tolerance fields. The designation of the thread tolerance field consists of the tolerance fields of the average diameter, d suffix 2, in the first place, and the outer diameter for the bolts, small d, and the inner diameter for the nuts, big D suffix 1, in the second. First place and second place, as you can see. For G, it's for average diameter on D suffix 2, and 6G, it's for the bolt, because you can see small g, and for the bolt, it's outer diameter of the thread. So you can see the designation M5 by 0.8, 4G, 6G. So M, it's metric thread designation. 5, nominal size. Its nominal diameter 5 millimeters. 0.8, it's pitch. 4G and 6G, it's tolerance class designation. 4, tolerance grade. G, tolerance position allowance. 6, tolerance grade, and G, tolerance position or allowance. For first place, it's pitch diameter tolerance symbol and crest diameter tolerance symbol. And our lecture is finished. Thank you very much for your attention. Goodbye. See you on the next lecture. Goodbye.